podcasts you love.
From people you trust.
This is TWiT.
Bandwidth for TWiT specials is provided by CacheFly at CACHEFLY.com.
This is TWiT Live Special 244, recorded April 13th, 2015. NAB Day 1. This TWiT Live Special of NAB is brought to you by Shutterstock.com. With over 52 million high-quality stock photos, illustrations, vectors, and video clips, Shutterstock helps you take your creative projects to the next level. For 20% off image subscription packages on your new account, go to Shutterstock.com and use the offer code TWiT415. Hey everybody, Scott Wilkinson here. I am the host of Home Theater Geeks and editor of avsforum.com. I'm here at the National Association of Broadcasters Convention in beautiful Las Vegas, Nevada, scouring the show for information about the tools that professionals will use to create the content that we consumers will enjoy in the future. In particular, I'm looking for things about high dynamic range and wide color gamut, high frame rates, the things that make Ultra HD, or what's sometimes called 4K, truly special. So come along as we visit a bunch of booths here at NAB. I'm here in the ARRI booth at NAB talking with Stefan Ukas-Bradley, the Director of Technical Marketing. And Stefan, I'm very interested in how images are captured, ultimately to be displayed in consumers' homes. I know that ARRI is very big in the camera business. Your cameras are used on all the major motion pictures. What's new here at NAB?
Well, we've been very fortunate. I mean, the Alexa, our first real digital, product, was introduced about 5 years ago, and it's still been the industry standard. We went through a couple iterations, and we grew the family a little bit. But it's been really a wonderful ride so far. So, the Alexa actually employs a CMOS sensor. It's a 3.5K sensor, and it's what we refer to as AIT. It's the area imaging technology. It's not just the sensor itself. It's the actual dye we use on the color filter array. It's the low-pass filter we implement. It's the color processing, the way we roll off the highlights. That's what makes the camera so filmic looking, and that's what makes it so widely accepted in this industry.
Now, it's interesting that the ARRI cameras up till now have been less than 4K resolution. You said 3.5K in this case, so how does that work with the emergence of UHD or 4K movies?
Well, we have 4K solutions with our camera system. Even though the sensor might not natively be 4K, we have a very, very great image quality with our sensor we achieve, because resolution is just one overall aspect of the image quality. There's dynamic range, there's signal to noise, and there's color fidelity, as just to name a few. So we are very happy with the image quality we achieve. So are our customers, and we do, like I said, have 4K solutions. You can either choose ARRI RAW and do a mild up-res to 4K UHD or 4K Cine, or we can do this now in camera with our Amira camera, which is our documentary-style camera, which employs the same 3.5K sensor. And again, we're using the 3.2K aspect of the sensor, or image raster if you like, and do a mild up-res to 4K UHD, which is 3840 by 2160.
Right, and you also introduced at the show here the Alexa 65, which actually has more than 4K resolution.
It is. I do have to qualify, though, that the Alexa 65 is a rental item only. It's done by our brothers in rental. And again, we're utilizing the same sensor, and we refer to it as A3X, meaning we're using 3 of those Alexa sensors and actually turning them 90 degrees and stitching them together to have the equivalent of a 65 millimeter film frame, actually a little bit larger. So the image circle for this camera is actually around 60 millimeters, and the resolution is 6.5K. So to be exact, 6540 by 3100.
Now, what about dynamic range? What kind of dynamic range can the Alexa and other RE cameras capture? Because this is, of course, a very important thing with UHD. Number of pixels is, in my opinion, not the most important thing.
Absolutely, I couldn't agree more with you. And when we first talked and consulted with some directors of photography, and we said, what is more important? Is it dynamic range or resolution? 70% of them said it was the dynamic range. And it's a trade-off because you only have a certain amount of real estate on a 35 millimeter sensor size, and the more resolution you have, the more pixels, obviously, and the smaller the pixel itself. So with that, you have less fill factor, worse signal-to-noise performance. So our pixels are actually fairly large, and we like to call, it's not the amount of the pixel, it's the quality of the pixels. We have the better pixel, we feel, and with that, the higher dynamic range. However, there is no real standard to measure dynamic range. So you will find in some advertisements, strange numbers. Some people think we are a little bit too conservative, but we feel truthfully that we have about 14.5 to 15 stops.
Which is plenty for high dynamic range TVs that we will see coming out later this year and next year and so on.
Absolutely. We're just glad that we actually have display technology now which actually can show the dynamic capabilities of our products.
Yeah. Well, hey, thanks so much for talking with us.
My pleasure.
Here in the JVC booth, I'm talking with Dave Walton, Assistant Vice President of Marcom. And Dave, when I came into this booth, I was amazed and thrilled to see some high dynamic range displays. Now, these are technology prototypes, nothing that we can buy today, but it points the way to the future, doesn't it?
Well, it does. A lot of research has been done, and there's a constant, nonstop effort to see how many pixels we can put on the screen. But research has shown that contrast is actually more important in determining picture sharpness than the actual number of pixels in the screen. So the next step in television and delivering and creating television is to improve the contrast or the dynamic range in the picture.
And what we're looking at here is a rear projection high dynamic range prototype based on JVC's DILA technology, right?
That's correct. Presently, the state-of-the-art in LCD has not been able to deliver the dynamic range for the extended dynamic range products that we had when we had a lot of plasma products. Plasma could do a very good job of very high dynamic range. Our DILA projection technology uses liquid crystal on silicone and has been shown to produce extremely high contrast ratios, and essentially has become the leader in both home theater, high-end home theaters, as well as in commercial flight simulators that airlines use to train pilots because of the very realistic images and the very high dynamic range they provide. So what we did is we built a couple of prototype projector, and these are rear projectors, that utilize DILA technology, and we have a live signal from a camera that we developed to produce HDR and feed a live signal right into the rear projector and actually show people live what it looks like.
See, this is the other very exciting thing for me, is a camera that can actually capture high dynamic range, because, the cameras that we've been using up till now and the content that we get is standard dynamic range. So I'm at this show very interested in finding products that will actually create the high dynamic range, and here you've got one.
It's not actually that difficult to build. CMOS and even CCD devices have historically had far greater dynamic range than the television standard that we are then putting them into is capable of delivering. So once the standard changes, the manufacturers will be fairly easily able to build cameras that have the extended dynamic range. Usually what happens is we have a chip that'll go out to, say, 300% of the video level in dynamic range. And we need, in order to process that much, we need, say, 14 bits of quantization to be able to process all those highlights. And then we squeeze it all down into 100 IRE so that we can put it into a standard video signal. We've got it there in the camera already. It's just that, what are we going to do with it? Well, now we've got something to do with it.
And I can't wait to see more of this. I'm particularly also interested in the demo you have here, the comparison of a standard LCD with another of these prototype little rear projectors with the high dynamic range. Let's go take a look at those.
Okay, let's walk over there.
Okay, here we are taking a look at this comparison, side by side, standard dynamic range on one side with a conventional LCD display, and this high dynamic range DILA rear projection on the other side. And the difference is so obvious and immediately apparent that it just dwarfs the whole idea of, well, you need more pixels, more pixels, more pixels.
Well, it's going to be hard for your viewers to see because you're feeding it all through a conventional television system. But yes, what we have is a conventional LCD and a rear projection DILA, which provides the higher dynamic range, and then a source that's coming from a computer that actually has the entire signal range. So it doesn't do any good just to play back a video on an HDR monitor, because that defeats the purpose. But once you have a source, and what's happening in the industry is that slowly standardizations committees are working on developing that into the standard, whether it's HDMI or whether it's Blu-ray or ATSC 3.0. You'll hear a lot about here because this is a broadcast show. ATSC 3.0 does accommodate high dynamic range. So in the future, it may be an option that will be broadcast over the air and then hopefully on into the cable boxes.
It's a bright future indeed. Thanks so much for talking with us.
Thank you, Scott. My pleasure.
What we're looking at here is a 2,000 nit prototype HDR high dynamic range display. Check out the fact that you can see these guys in the dimness and the detail in the bright outdoors outside that window. It's really amazing. Boom! We hit an outdoor scene. And we have beautiful detail in the rocks. We also have a very wide color gamut. This color red of this car is much deeper red than what we normally see on an HD TV or even a current UHD TV. It's a wide color gamut. It's even wider than the cinema color gamut of P3, I'm told. And but the big story here is high dynamic range, and it's just remarkable. Here's another example of that red in that pool table. Now look at the door right here. You can see all the detail outside as they come into this dark bar. That's what HDR is all about. Here's another example a little bit. The reflection on this guy's face. Here we're looking outside the window. From within this dim bar, you can see the low light detail and the highlight detail. This is the future of imaging, and it's just stunning. This is a prototype now. It's not a product. It's not going to be available next week, but it is pointing the way to something pretty amazing. Passing by the Canon booth, I saw something really remarkable, some incredible high dynamic range reference monitors, some of which are coming to us pretty soon. I'm talking with Chuck Westfall, the technical information advisor at Canon. Chuck, what can you tell us about these new monitors?
Well, we've actually got two of them now. We introduced the DPV 3010, which is our 30-inch version, last year, and it's been out in the market and doing okay. We also, at this show, are showing the new DPV 2410, which is the world's smallest 4K reference display. And it's also a 400 nit, so it's twice as bright as the DPV 3010, and that means that it's going to be a fantastic option for people who want to do HDR.
These are for monitoring in the grading suite and so on. They're not consumer products, but we can only hope that eventually this technology will migrate into the consumer world.
Yeah, at some point we would definitely like to be able to go that direction, but right now we're really concentrating on the pro and industrial side because they need the performance levels that these monitors have to offer.
And once they can do it, then they can create the content for the consumers. Now tell us, there are some very interesting features about this monitor. For example, it can take the raw footage from a Canon C300 Mark II, I believe, and just display it directly.
That's one of the most important new features on this DPV 2410, so that you come right out of the 3G SDI ports on the C300 Mark II and directly into the monitor, and you've got a live feed.
Amazing. What else can you tell us about these monitors?
In addition, there are 8 LUTs built in, including
lookup tables. We
Yes.
were talking here.
Sorry.
all right.
And essentially with those lookup tables, we are supporting all the major color space that people are going to be using, like the 2020 as well as the DCI P3 Plus, and also the new ACES proxy. So there's definitely a lot of attention been paid to trying to improve the workflow and streamline that whole aspect of it.
Are you telling me these monitors can actually display 2020?
Yes, they can. They've got the complete range on 2020 in terms of that gamut.
That's amazing. Now, we saw also a prototype of the 2000 nit monitor. Now, that's just a prototype. It's a technology demo, I think. It's not a product, coming soon to market, but it's quite remarkable.
Yeah, and it shows really Canon's commitment to the 4K reference display area, and this is something that we're very definitely serious about. We anticipate that going forward that the value of the higher brightness displays is going to become more and more apparent.
Well, this is really remarkable, and I thank you so much for joining us.
Thanks, and if you need more information, please come visit us at usa.canon.com.
I'm talking with Thomas Curley, Business Development Manager here at Panasonic. And Thomas, you've got some good news regarding the GH4 mirrorless camera that involves some new lenses.
Well, we have some exciting news with the very popular Lumix GH4 camera. This is a mirrorless camera, interchangeable lenses. It shoots 4K video, and it has a 4/3 sensor in it. We introduced it last year here at NAB Show, and we're back this year with some exciting news involving a firmware update that provides anamorphic capability.
So what that means is that you can put an anamorphic lens on this camera, which stretches the image horizontally, as I recall, and lets you shoot widescreen without having a widescreen image sensor.
That's right. So what we do is we shoot in 4:3 aspect ratio. We mount a third-party lens on it with adapters that are available, or a 4/3 anamorphic lens as they become available from the partners we're working with. And then through the firmware in the camera, we're making maximum use of the sensor and then enabling that to be recorded either to the SD card in the camera or output through HDMI at a higher color space, 10-bit. And then we can use traditional post-processing editing capabilities to stretch that out to a full anamorphic aspect ratio.
So if you record outside the camera, you can get 10-bit. Inside the camera, you're limited to 8-bit, correct?
Yep, 8-bit 420.
And what about the external 10-bit? Is it any more than 420, or are we still using the same color sampling?
It's 422.
Okay. Fantastic. Now, this camera's been out on the market for a while. The firmware update available now?
Firmware update will be shipping within the next 30 days.
Well, your demo here looks really great, and certainly having the ability to shoot widescreen content with such a small camera sounds like a great thing to me.
Mm-hmm. We're also coupling what we're showing here with a new log gamma color space, so we can shoot with a very flat and then grade in post after that.
And this what's called V-Log-L, I believe?
That's correct. It's called V-Log-L. We're demoing it here at NAB Show. We have not set a release date for it, but there's so much interest in it, we wanted to show it. We've had some content creators out there shooting with both the anamorphic format and the V-Log-L to evaluate it and test it. And we're showing the results here and getting the feedback. We're excited about both of these things.
Now, the V-Log-L will allow this camera to shoot more high dynamic range, right?
That's right. We're now able to capture 12 stops of range.
Fantastic. Thanks so much.
Thank you very much.
At Shutterstock.com, you'll find the perfect image or video for your next creative project. Whether it's for your website, a publication, an advertisement, a video, or any other type of project, you can choose from over 52 million high-quality stock photos, illustrations, vectors, and video clips. Shutterstock sources images from around the world and puts them at your fingertips. Many contributors to Shutterstock are professional photographers and artists. Shutterstock reviews each image individually for content and quality before adding it to its library. Shutterstock adds 385,000 images every week, so every time you visit, you'll find something new. Shutterstock has flexible pricing. You can choose individual image packs or a monthly subscription for the best deal. You can download 25 images per day with a standard subscription. And you can download any image in any size and pay only one price. Shutterstock gives you the images you need to bring your creative projects to the next level. And they make it easy. Shutterstock has sophisticated search tools. You can search and drill down by subject, color, palette, file type, gender, emotion, and more. Shareable lightboxes let you save images to a lightbox gallery, then access them anytime and share them with other team members. An award-winning iPad app lets you search on the go and use it to display images during presentations. Shutterstock is a global marketplace. They have multilingual customer service in more than a dozen international countries and full-time customer support throughout the week. You can try Shutterstock today by signing up for a free account. No credit card needed. Just start an account and begin using Shutterstock to help imagine what your next project could be like and save favorite images to a lightbox to review later. Once you decide to purchase, use offer code TWiT415 and new accounts will receive 20% off image subscription packages. That's Shutterstock.com, and for 20% off image subscription packages on new accounts, use the promo code TWiT415. Next up in the Panasonic booth, I'm talking with Steve Cooperman, Senior Product Manager, and we're talking about the VariCam 35 with a new capability. Tell us what it is.
Yeah, thank you. The VariCam 35 is unique in that it has a dual ISO setting. It has dual native ISO 800 as well as ISO 5000, and it opens up unique shooting opportunities.
Yeah, the ISO 800 is a pretty common sensitivity in digital cameras, but 5,000, holy smokes.
Yeah, so let's say if you're shooting in standard bright lighting, a lot of the competitive cameras need lighting, and you're using ISO 800. But there are situations where, for multiple reasons, you have to shoot in dark situations. Things like maybe you're outside, maybe your production company can't afford lights, or maybe physically you just can't get the right amount of light into a small or unique shaped place. Or maybe it's in an emotional, dramatic, romantic kind of scene where you actually want the mood dark to help the actors with their creative craft. In that kind of situation, up to now, you would have problems with the video. You would have noisy video when you turn up the gain on the camera. The unique capability of the VariCam's ISO 5000 setting is it allows you to work in very low light and still get very clean, sharp-looking video in full 4K resolution.
Now, the demo here, we're showing in the low light setting with the ISO 5000. I think I heard one of your colleagues say that we're talking about half a foot Lambert or half a foot candle. I forget exactly what it was, but it was very low light.
Amazingly low light. That's shocking for most cinematographers and producers. So again, it's important for all levels of the production. The producer, the director, the DP. It helps with the creative aspect as well as the production business aspect of shooting movies.
So what else is new with the VariCam 35?
Yeah, one unique thing that we also have with the VariCam 35 is the ability to record uncompressed, raw, 120 frame a second 4K content. And that's actually done here with the Codex recorder. And we're showing it here for the first time at NAB 2015. Should be shipping this June. And it opens up unique workflow opportunities. One of the great things about the VariCam is we have phenomenal in-camera 4K recording along with 2K sub-recording and even proxy. So we have high-quality recording along with a great workflow. But there are times where you need even higher quality recording for top-notch Hollywood movies, for commercials, for situations where you're going to have high-end compositing and graphics. And in those situations, that's where this Codex recorder comes in when you do need uncompressed, raw 4K for the highest video quality.
What is the dynamic range this camera can capture?
Well, we officially say it's 14 plus stops, but we have had customers and independents measure at higher levels than that.
And it's using this V-Log gamma as well to achieve that, right?
The camera has a nice V-Log curve for very pretty video quality.
Well, it's an amazing camera. Certainly this low light capability is wonderful, and thanks so much for sharing the information.
Yeah, thank you very much.
Tons of camera news here in the Panasonic booth. I'm talking with Jim Wickheiser, Senior Marketing Manager, about the DVX200. It's essentially a camcorder, isn't it?
Yes, it is. It's really a brand new 4K camcorder. It uses a full 4/3 inch imager. It records at 4K up to 60 frames per second.
And what else can you tell me about it that's special?
Well, it makes it very easy to shoot in 4K. It has a fixed lens, a very wide fixed lens, so it makes it easy to shoot and focus and get really good shots in 4K. But it has a lot of great high-end features like a V-Log L curve, which gives you up to 12 stops of latitude.
Which is great in this day of high dynamic range, isn't it?
Absolutely. You want to get these great, rich, dense pictures to really make the beauty of 4K.
And the price point's pretty nice too, isn't it?
Yes, it'll be available this fall at a price of under $5,000.
Man, it's just it's going to be just great in the future being able to record all this stuff.
Yeah, 4K is really a reality today, and we're transitioning from HD to 4K, and products like this will make the transition happen even quicker.
Great. Well, thanks so much for sharing the information.
Thanks, Scott. Glad you can come to NAB.
Now, over in another part of the Panasonic booth, I found some really interesting laser projectors. I'm talking with Carl Demands, product manager here. And Carl, what can you tell us about these new laser projectors?
Well, Scott, actually, these are the latest in technology. They're 3-chip laser technology, basically delivering 20,000 hours of continuous operation use. Also, because they're laser technology and they're liquid cooled, you can mount them at any position, vertical, horizontal, pointing down on various angles. And being laser-based technology, not only do you get the longevity of a maintenance-free product, but also you get an amazing contrast ratio. You're talking 20,000 to 1, hitting the entire Rec 709 gamut and approaching that for the Rec 2020 gamut moving forward.
So at the moment we have Rec 709, probably you can get out to P3 with these lasers. I mean, they're separate RGB lasers, right?
Actually, these are not separate RGB lasers. These are blue lasers, all based on the phosphor.
Okay, so it's what's called blue pump phosphor. Blue lasers, yellow color, yellow phosphor wheel, which is then split into red and green, giving you the red, blue, and green, some of the blue coming from the laser.
Correct. Everything that's then recombined to give you your color accuracy.
Right.
Yeah.
Now, this one that we're looking at here is an ultra short throw, and when is that expected to be available?
Oh, the actual short throw lens is available today for all of our 3-chip. The amazing thing that we have out there is all of our lamp-based 3-chip projectors and our laser projectors will use the same lamp structure. So what we're doing here in the booth today is something nobody else in the industry can do today. We're taking a 3-chip, 10,000 plus ANSI lumen projector, creating a 180-inch image in less than 4.5 feet of throw distance. So if you're in a production studio where space is limited or constrained, it is the obvious solution.
Wow. And then we have another bigger guy over there. Is that the same guy?
No, that's not the same guy. That is the big brother to the RZ12K. That's a 10,000 lumen 4K projector.
This one we were looking at earlier is 1080p?
Correct. It's a WUXGA 1920 by 1200.
Got it. And yet here we have a 4K.
And there you have the 4K. Actually, Panasonic has some unique technology in that as well, where we actually use a less than native 4K resolution chip, but actually quadruple the frame rate to eliminate the screen door effect you get from DLP, so it's a much more film-like experience. It's really an incredible technology that needs to be seen.
And when is that due out?
That'll be due out, November, December timeframe.
Well, I can't wait. Thanks so much.
Thank you very much. Thanks for stopping by.
You bet. At yesterday's Tech Summit on Cinema, I saw a demonstration of a remarkable new camera and recording technology called Lightfield. And that was developed by Fraunhofer over in Germany, and I'm talking with Frederick Zilli, who's the group manager of computational imaging and algorithms. Had to read that to get it right. Frederick, tell us about Lightfield technology.
Yes, Lightfield allows new special effects in post-production. For instance, you can set a new focus point in post-production, you can render virtual cameras, you can relight your scene, so there are lots of new opportunities.
Now, the way that you can do that is by shooting with an array of cameras rather than a single camera, right?
Exactly. We have used for our short film, which we produced, an array of 9 cameras along with one with so-called hero camera, so one standard cinema camera, and an array of 9 smaller cameras.
And so how does shooting with an array of 9 smaller cameras let you do things like relight, refocus, change the perspective? Well, I can see how you could change the perspective because you just use one or the other of the cameras, right?
Yes. I mean, the main novelty, if you want, is the depth map. Yes. So we can create depth maps for all cameras and, of course, also for the hero camera. And in addition, we can create normal maps for the objects. And this allows to use elements known from computer-generated imagery to apply to live-action footage, such as relighting, adding new light sources, etc., etc.
And you've also developed a tool for manipulating these images in post-production in a common environment that people who do this are used to, called Nuke.
Yes, in fact, that's true. We want that our new algorithms can be easily accessed and so that they can be integrated into a current workflow. So we decided to integrate these tools into different plugins which can be used inside the Foundry's Nuke. And this includes also import filters and processing filters for the multi-camera data.
To demonstrate this technology, you shot and produced, I guess, a tiny little short, which is sort of a fake commercial. It's very funny. I saw it yesterday of, I guess it's a hitman coming in from his job as pretending to be an instrumentalist or a violinist and sitting down and drinking some tea. It was hilarious. What were some of the effects that you used in that?
Well, we made use of the relighting technology, refocusing technology, depth-based compositing. So instead of using a green screen, you can now compose different scenes using depth-based mattes. And this were the main new aspects in this short movie.
Is this short movie available to see, like on YouTube or something like that? How can people look at it? I mean, it's so interesting.
Well, we have shown it yesterday at the DCP at the summit. We have done this together with the Stuttgart Media University, and that's also they have also introduced this creative flavor, let's say, what you just mentioned, and together we hold the rights for the DCP, and it can be accessed on demand. So if you need it, we can find a way to show it somewhere else. Yes.
Well, I was just curious to see if our audience could be able to go and see it. Is it just generally available or only by special arrangement?
At the moment, it's not free for download, but we will find an arrangement. Yes.
Fantastic. Well, it's an amazing technology, really interesting, and I wish you the best of luck.
Thank you very much.
Here in the Sony booth, I'm talking with Hugo Gagioni, CTO and VP of Technology at Sony, and we're talking about high dynamic range, the big story of the show, really. Tell us what you're showing in that regard.
Okay, what you see behind the F2 mastering monitor is the BBM X300. It's an OLED display with true 4K. 4096 by 2160, and it's capable of reaching 1,000 nits of brightness. Okay? And it has a number of gamma curve. We can do 2.2, 2.4, and also support the gammas that we use in cinematography. Then what we did was we took an F55 camera, and we shot this very critical piece in RAW, and then we color graded the RAW. And we did 2 color gradings, one in SDR, and one in HDR. But in order to capture the more than 14 stops of dynamic range that we have in the cinematographic camera, we have 16-bit linear. The cinematographic cameras are totally linear. To take that 14 stops to put it into 10 bits, because these are 10-bit displays, we have a curve which is called S-Log3. S-Log3 is a curve precisely matching our sensors in the F55 and the F65 cinematographic camera. Then, in the monitor at right, I introduce an inverse S-Log3 that completely linearizes the light. Therefore, what you are watching here is 14 stops of linear light coming at you. On the other one is graded in a standard dynamic range using a 2.4 gamma. Therefore, the inverse curve is a 2.4, giving you 100 nits. Therefore, a standard dynamic range, 100 nits, high dynamic range, 1,000 nits.
So if you grade to a high dynamic range with 1,000 nits, how are you expecting that consumer TVs ultimately will have that kind of performance, or how do you manipulate it then to go into consumer TVs?
The TV sets that are now going out in the street for the consumer application from anybody, from all the other manufacturers, we are in the vicinity of 1,000, 1,300 nits. That's commercially available today.
So those TVs do have the capability right now.
Yes.
They might not have the curves that you're talking about.
Yes, that's absolutely correct. One issue with high dynamic range is that we are waiting to see what's happening in the industry. I mean, both in the consumer side as well as in the professional side. In professional applications, we use S-Log3 because we have to produce a perfectly finished material. Then, once it is satisfactory, we will use whatever curve for distribution. I can do a Blu-ray using SMPTE 2084 or any other curve. But these are all color grading process in non-real time. The problem that the industry is facing is how do we do high dynamic range for real-time broadcasting?
Like sports or concerts or anything.
You're not going to color grade a baseball game on the fly.
Right.
And what the industry is looking is for a backward compatible curve, because there are billions and billions of TV sets that use 709. Therefore, there are international efforts right now to define a curve that is backward compatible with 709. And it will do a good job.
But we don't have it yet.
No. This has been discussed as we speak. And when that curve is standardized, then very likely we will put it in our studio cameras. That's no problem.
Any idea when that might be? A year, 2, 5, 20?
It has to be finished by July of this year.
Well, then, these are exciting times, aren't they?
Do or die.
Thank you so much.
My pleasure. Thank you.
I'm standing in front of another high dynamic range versus standard dynamic range demonstration here in the Sony booth. And as you can see, well, maybe you can't because we're not shooting in high dynamic range. But on this side is a standard dynamic range TV. It's the X850B 4K TV from Sony, currently available. And on this side is a prototype high dynamic range set. Doesn't have a model number yet. It should be out in June, apparently, with high dynamic range capability. And what we're looking at is content graded for standard dynamic range over here and high dynamic range over here. You can clearly see the difference. Well, if you were standing here with me, you'd be able to clearly see the difference. Not only is this much greater dynamic range with deeper blacks, brighter highlights, but also the colors are even different, because in high dynamic range, that also affects the color gamut, the range of colors that one can reproduce. So we're seeing at this show quite a few of these comparison demos, which just go to confirm for me what I've already known, that high dynamic range is the wave of the future. That is what's going to really make the picture pop so much more than it does now and make Ultra HD truly the next generation of video. Over on the camera side of things at the Sony booth, I'm talking with Steve Flynn, System Camera Sales Support for Sony, and we're talking about a new camera here at NAB. Tell us about it.
It's the HDC 4300, just introduced to the world yesterday. It is our first system camera that uses 4K acquisition imagers, 3 CMOS imagers at 4096 by 2160 resolution.
Now, we're also seeing a demonstration here of its capability of capturing a much wider color gamut.
Yes, it does. It meets the ITUR BT 2020.
BT 2020, so it'll actually capture 2020. And the question is, there aren't very many monitors yet that can display that, but they're coming.
Well, we have our OLED monitor here that we're showing, our new 30-inch OLED display that's just introduced recently.
Right.
And being shown exclusively at this NAB.
Another feature of this camera, I understand, is its high frame rate and ability to do slow-mo.
Yes, it does. It has the ability to capture, as standard, it will capture 1 times, 2 times, or 3 times HD. And with an option, the SCZ 4002 option, you can capture at 4 times, 6 times, and 8 times 1080 60p, or 1080p times 4, 6, and 8 times.
But you can't do that at 4K resolution.
4K resolution is 60p max. We're a little bandwidth limited on the transmission.
Anything else you want to tell us about this little puppy?
Come on down and take a look at it if you get a chance. It's a really great camera. We have a lot of our high-end customers that are very excited about this camera system because of its flexibility and the ability to do 4K and the ability to do high frame rates.
Does it capture a high dynamic range?
I'm not sure if it does capture a high dynamic range. I know HDR is generally used for cinema-type cameras. This is a 2/3 inch camera. Where the excitement really exists in this for live television production is that 2/3 inch format lenses can be used with this camera. Therefore, camera positions can maintain the legacy of the camera production. The system production is a legacy type thing that's based on lens capabilities.
Right. So this can fit in right exactly where the cameras have been before, while offering these enhanced capabilities.
You can position the cameras as you did before, whereas with 35 millimeter PL type lenses you could not. And if you did, there was a trade-off. You usually lost your sensitivity and you did not have the zoom ratio. So it was very hard to position a camera as in previous 2/3 inch models. With this model, the end user now has the ability to get high frame rates and high resolution using the same camera positions that they had previously.
Sounds great. Thanks so much.
Thank you.
Here in the Christie booth, we're looking at a laser-illuminated projector for commercial cinemas. I'm talking with George Shekel, Director of Business Development. And George, tell us about the new laser projector.
Yeah, what we're demonstrating in the booth is our 4K laser projection system. And it's utilizing our laser technology, which is supplying the light source for the projector as compared to xenon. So the demonstration that's occurring is about demonstrating the color space for high dynamic range, the color space for cinema, which is commonly referred to as P3, and the color space for HD, which is Rec 709, and the color space that you typically see on an HD TV. And our illustration here is to show the broader color gamut that you can get on a laser projector compared to what you typically see in a normal viewing environment. Now, it's illustrating things that creative people will be able to do that go well beyond what you see today for the purpose of art, okay? So even though it's a technology demonstration, we're exploiting it here just to illustrate the palette that they have to work on compared to historical profiles.
Well, these are tools to create and preserve the artist's intent, the creative vision.
Exactly, exactly.
Now, I have a question for you about Rec 2020, or sometimes called BT 2020, which is easy to do, relatively easy to do with lasers because they're very narrow wavelength bandwidth. But that can, I've heard, lead to something called metameric failure, which is where if somebody looks at a picture with a certain color and somebody else looks at that same picture, they won't perceive the same color.
Right.
How do you deal with that?
Well, that's one of the artistic elements of this that is the uncertainty. But that's true in film, that's true in other technologies that have been implemented.
Except for the fact that xenon bulbs, for example, have very wide bandwidth primaries, and so that particular problem does not come up nearly as much.
Right. So what we do is an implementation that tries to mitigate that by using different wavelengths to help support let's say a diversity of the color spectrum, so it's less subject to happening.
And does that also help with speckle reduction? I know that laser projectors have a problem with speckle.
That's correct. It helps to mitigate some of the speckle because you're offsetting the wavelengths.
Now, you mentioned high dynamic range, and I know that this projector can output, well, I don't. Tell me what's the peak white that it can output?
Oh, the projector can output 60,000 lumens, so it's a very powerful projector.
And even at that, I believe, I would assume that it gets pretty good blacks, too. It can really get down there because you can turn off the lasers.
And absolutely. They go completely dark, so you get very high contrast ratios, well above 2,000 to 1.
Yeah. Which, and the cinema standard is like 100 to 1, right?
Right. So it's 20 times.
Yeah. So is this in commercial cinemas right now? Or
It is, as a matter of fact. There's one at Cinerama, which is it's Paul Allen's theater up in Seattle, and it's showing regular full-feature films from the Hollywood studios. There's others in Moody Gardens down in Houston, Galveston area, and we're deploying them in a wide array of location-based entertainment as well as cinema applications. So you'll see an emerging footprint as we go over out the next few weeks.
But doesn't this also mean that the content needs to be graded for this type of projection system differently than it has been in the past?
Yeah, typically you want to grade the content for whatever target your device is for display. So as you see improvements in 3D brightness, you'll see different grades of brightness for 3D distribution. As you see changes in the color spectrum, you'll see changes to that particular footprint. Not making everybody happy about a single format release, but the reality is everybody's trying to push the limit on what is possible.
Right. Well, thanks so much for talking with us.
You're quite welcome. Thanks for coming by.
Here in the SMPTE booth, I'm talking with Howard Luck, Director of Standards at SMPTE, and also a director.
Yes. Anything with a director in the title, I'm fine with.
Yes, you're good. Okay, good. So first of all, before we get to standards, I just want to mention the movie, the documentary that you're making on SMPTE, about SMPTE, called Moving Images. Tell us a little bit about that.
Well, SMPTE is coming on its 100-year anniversary next year in 2016, and so part of that process, what we've decided to do, or SMPTE's decided to do, is document the history of SMPTE and the history of motion pictures and television broadcasts through those 100 years, which is a huge area to cover. So that's basically what the documentary is about. We've just been working for a couple of months, so we've got a sizzle piece that we just showed here at NAB on Sunday to a fairly large audience and got really good response on it. So we'll pause for a moment after this, catch our breath, and then get back into production starting in June and finish up at the end of the year and get into post. So
I was one of those in the audience, and I saw the clip. It looked fantastic. I was very interested to see, you're using a bunch of clips from very old movies and then some more modern ones, but you're shooting all the modern interviews in 4K. That's pretty cool.
Yeah, well, we decided since it's 2016 and UHD TV is coming out and theatrical is already 4K that we'd be a little bit behind the game if we shot something in something lower than 4K. So we were very lucky to have Canon support us with that and give us 2 cameras and lenses, the C500s that we're shooting in 4K. So it's been fantastic with that, and it'll hold up. And then the best thing about it, I think, too, is it's fascinating that the stories that we're getting from these people about the times and the milestones in the industry of motion pictures and television broadcasts. So it's a great historic vault that we'll be putting behind us when we get done with it as well, too. So why not shoot it in 4K?
Sounds good to me. So now let's turn to SMPTE standards, which you're an important part of. You're helping to develop and coordinate anyway. What is the state of standardization? Let's start with HDR, high dynamic range. I'm pretty sure that's been settled now, right?
Well, it's one of those things that's fairly new still. There is a standard that's been already done and completed and published. I don't know exactly the number because I don't keep track of the numbers too much, but it does kind of codify the Dolby's PQ system and their transfer function for that, the metadata that surrounds it and things like that. So that's now moved out of the standards process and it's published, and so now manufacturers can actually build and design to that. And HDR is, as you've seen at the show here today probably, is really bubbling up pretty big. A lot of people are excited about it, including myself as a creative. It gives us a lot more possibilities with a wider contrast palette, so it's very, very exciting in that sense.
What about immersive audio? There are a couple of things going on there. Certainly, I saw Brian Vessa give a talk about how now when you want to do Atmos or you want to do Oro or you want to do DTSX or something, you have to do it all over again. And he's trying to work on a standard whereby creatives only have to do it once and then it can get rendered out to anything they want.
Yeah, well, it's always a process that kind of keeps repeating itself. Somebody comes up with an innovative idea in the motion picture industry and starts to do a proprietary system that gets out in the field. And then another person wants to compete with that and does another proprietary system. And we end up with these multiple proprietary systems, which then for a content creator becomes a real nightmare because you have to deliver a specific mix for each one of those distribution systems. So SMPTE, what it tries to do is bring those competing systems together, try to get everybody inside of a room, and try to hammer out something that would be a consensus among those competing systems that would be a standard that would then allow a certain standardized file to cross each one of the systems in it. So that's kind of the process that's happening now with the immersive audio. It usually starts as a study group to study what's going on in the field. It writes a study report that's already been done for immersive audio, and then from that they kind of know the direction to head into to try to get a standard done with that. So that's kind of one of those things that are in process. At the moment we don't have that, so those content manufacturers that are creating immersive audio now have the burden of doing multiple mixes at the end of their show to get this out to the world. So hopefully we can resolve that sooner rather than later.
I hope so as well, and I'm sure you do as a creative.
Oh, yeah.
Now, what about codecs? That's another issue where there are a number of them out there, and certainly I think GoPro just recently, you're working on standardizing their codec, and there are some others. There's an Apple ProRes that you're working on, and so on. Why are all these codecs out there? I mean, isn't MPEG good enough?
Well, MPEG was designed quite a while ago and was fantastic at the time that it was designed. But as we get better and better at the algorithms and the human visual system, and you understand more and more, we can actually create better compression systems that are much more efficient or much more quality-based. So one compression system doesn't fit the shoe for everybody for a long portion of time. So in that case, a lot of these things bubble up. GoPro had brought what is now going to be called VC5 to the SMPTE standards process and has gone through the full SMPTE standards process to make that a full standard that's going to be published, if not published already, I think, that people can actually build and manufacture equipment to. ProRes, on the other hand, is actually doing it as a registered disclosure document, which is more of we're taking their word of everything that's in the document. We're pretty much certifying that it is at least in a correct template. It's got all the parts to it. Technically, it's accurate. And then that will be disclosed out for people that want to pull that. But it's not necessarily a standard. So there's a difference between an RDD and an actual standard, if you will. There's also recommended practices and engineering guidelines, but I don't want to bore you guys with all that stuff right now. So.
We should say that ProRes is not something that consumers would see. It's something used within the production and post-production process, within the workflow, to reduce, I guess, file size to some degree without compromising quality. And it's also an Apple-specific codec, right?
Right. So it's been kind of an Apple closed ecosystem at the, up until this point in time, and them doing a registered document, basically. And it's designed for professional work to be done. It's been, though, out in the field for quite some time. It's a very good codec. It works very, very well. A lot of the codecs work quite well these days. So it is out there in the field and all across, in a lot of places. So we prefer that these things become standardized because then we can have a lot more interoperability and keep it not just a closed ecosystem, but we can use it with other ecosystems as well.
So does that mean that one could ultimately imagine seeing a ProRes on a Windows machine?
We would love to see that. I don't know. That's kind of a business decision, so I really can't comment on that. Yeah. But if Apple comes forward even more and makes it a standard, then yes, you could absolutely see that. Licensing issues aside, because that's not something that SMPTE gets into. But yeah, absolutely, that would be, I think, a huge benefit for the industry as well.
So we've talked about immersive audio, we've talked about high dynamic range. I guess color gamut is pretty well set now. We've got 2020, we've got P3, we've got 709.
Yeah, color gamut is pretty much set, and we also have another production tool that has come in and just recently been actually put out in the world, and that is ACES. So that is the Academy color encoding specification. They finally did 1.0, put it out in the field. SMPTE will follow up with the standardization on those pieces that are not standardized already. There's already some that are done. That's a huge gain in the production environment that allows us to interchange high resolution, high dynamic range, high color gamut, wide color gamut material, and then keep that in an archive situation as well too, so that somebody down the road 20, 100 years can actually understand what those files look like. So that's working on in the gamut side. 2020 is here. That's opening up a lot of new things in the industry, a lot of new troubles for display devices to make it to 2020, a lot of cameras to support 2020 and workflows. So it's a new thing. It's exciting.
Yeah. But as a creative, what is your thought on 2020 and the problems that it has? The one problem that I know about particularly is called metameric failure, which is because you have the primaries, red, green, and blue, are so narrow in their bandwidth that this causes different people to see colors differently.
Yeah, so it can make the problem worse with the metameric issue. So in other words, if you pull off the bumper pads, I like to say, and you let everything go as far as the color gamut that we can see as human visual system in the real world, then you start opening up this issue that some people see color a little bit differently than other people. Now, if we're watching different things at different times, it doesn't matter. We'll see it maybe a little bit different. Okay, that's fine. Yeah. But if you have a bunch of creatives in a room that are very picky about the color on the screen, and we've opened up this wide gamut of color, and we have colors that push out in those boundaries, this is where you start seeing those metameric problems that come up, right? So, it's always easier if you contain the color gamut into a smaller size. You don't have those problems. But at the same time, that doesn't let us go to the future and show things like stained glass and tail lights and those things, like LED lights, all those different ones that really push the boundaries for that color gamut, if you will.
Getting back to dynamic range, in the Canon booth, we saw a prototype of a monitor that gets up to 2,000 nits peak bright and was able to show shots inside a dim bar with a window looking outside, and you could see the detail outside and the detail inside. It was remarkable. I'm sure you're looking forward to something like that, huh?
So that is the most exciting thing for me as a creative, is to have that wide latitude between the really blacks and the really brights, because we as humans see that every day in everything we do. So it would be nice to be able to represent that on our display devices, both in the theater and at home. So HDR to me is the most exciting new kind of thing that's bubbling up within the industry. Wide gamut has kind of been solved to a certain extent, and it's exciting, but it's not something I would tend to push the boundaries on that side of the equation. But the HDR stuff is really interesting. High frame rate is interesting in its own right. It comes with different characteristics we need to study a little bit more between the soap opera effect versus the dramatic 24-frame effect. But there's some really good research that's going on right now at the time for that stuff.
One more question about dynamic range, and that is there are a number of systems out there already. There's SMPTE 2084. I happen to know that particular number, not all of them, but that one. There's Dolby Vision, of course. Yeah. There is something from Technicolor. There's something from Philips. There's something from BBC.
Yeah, so again, now we have all these competing proprietary type of formats for
exactly
HDR, and we're back in the same boat we've been with codecs and things like that.
Exactly.
So you can see the cycle continues. But I think that's the thing that SMPTE really tries to do the best work in, is to try get these people to the table, get them to agree on a certain type of a standard for this stuff that we can then interoperate between each one of them. And the HDR is a new up-and-coming field with that stuff, so we do have these competing systems that are out there. And then, again, we do have a lot of standards, and you kind of pick and choose the standards you want to use.
I'm convinced that in terms of immersive audio, things like Dolby Atmos, DTSX, Oro, they can all coexist. But I'm not quite sure if all these different high dynamic range standards can. Because if a TV implements one or the other of them, a monitor, say, and it receives a different one, what's it going to do?
Yeah, and the other myth that's kind of out there right now, that high dynamic range has to do with the brightness where the nits are, but it's actually more about the contrast. It's really about contrast ratios. And then what do you set for that target nits and how the display systems react? For example, a home system should be able to move up and down with the ambient light in the room, because not every living room or system or TV is in the same ambient light, right? And so as a creative, you want to have it reproduce exactly as close as you can as you did at the studio. So it would be nice to have smart TVs that would actually adjust up and down their dynamic range to show that as well.
Well, they do to some degree at this point, but I guess it's not very good.
Yeah, it's still in its infancy. There's some of it, and some of them I heard stories where you turn off the light and it booms around a bit, it starts bumping around and things like that. But again, it's still early time, so we're trying to figure this stuff out. But
well, it's very exciting times, no doubt about that. Thanks so much.
Absolutely, thank you.
At Shutterstock.com, you'll find the perfect image or video for your next creative project. Whether it's for your website, a publication, an advertisement, a video, or any other type of project, You can choose from over 52 million high-quality stock photos, illustrations, vectors, and video clips. Shutterstock sources images from around the world and puts them at your fingertips. Many contributors to Shutterstock are professional photographers and artists. Shutterstock reviews each image individually for content and quality before adding it to its library. In fact, Shutterstock adds 385,000 images every week, so every time you visit, you'll find something new. Shutterstock has flexible pricing. You can choose individual image packs or a monthly subscription for the best deal. You can download 25 images per day with a standard subscription. And you can download any image in any size and pay only one price. Shutterstock gives you the images you need to bring your creative projects to the next level. And they make it easy. Shutterstock has sophisticated search tools. You can search and drill down by subject, color, palette, file type, gender, emotion, and more. It also has shareable light boxes. Save images to a Lightbox gallery, then access them anytime and share them with other team members. An award-winning iPad app lets you search on the go and use it to display images during presentations. Shutterstock is a global marketplace. They have multilingual customer service in more than a dozen international countries and full-time customer support throughout the week. You can try Shutterstock today by signing up for a free account. No credit card needed. Just start an account and begin using Shutterstock to help imagine what your next project could be like and save favorite images to a Lightbox to review later. Once you decide to purchase, use offer code TWiT415 and new accounts will receive 20% off image subscription packages. That's Shutterstock.com, and for 20% off image subscription packages on new accounts, use the promo code TWiT415. Here in the Dolby booth, I'm talking with Giles Baker, SVP of Broadcast at Dolby. And Dolby's got some interesting news here at the show. Let's start with Dolby Vision.
We are really excited about Dolby Vision at NAB. We're very proud to announce the first Dolby Vision consumer televisions, announced with our partner Vizio today, and it's a very, very exciting time for us because we're going to see consumer TVs with Dolby Vision, content in Dolby Vision, and the ability to actually get that content through our partners with Vudu and other partners going forward. So Dolby Vision is coming to a living room near you.
Now, is Vudu going to be the first way that it's going to be delivered, that we're going to see it?
That's right, yeah. So one of the things we're showing here at the booth is the ability to interact directly with the Vizio Reference Series TV, go onto the Vudu site, choose a Dolby Vision movie, one of the 6 that we've already started working through with Warner Brothers and that will be available, and just watch it on the television.
It's quite amazing. Now, in regards to Atmos, there isn't really any news as far as the format is concerned, except for the fact that we are now starting to see a respectable number of titles, which I'm really glad about.
Yeah, it's amazing how, you get the first couple of titles out and then the wave really starts. We're very lucky that we have over 200 titles in the cinema available in Atmos, so there's a pretty healthy flow of content. But we're now seeing over 25 titles available on Blu-ray in Dolby Atmos available to consumers, and it's just going to grow and grow from there, so it's a good thing.
Well, certainly having those over 200 theatrical releases should make it easy for the studios to adapt to Blu-ray or to streaming for that matter, but I've been surprised at how slow they've been coming out. Now, hopefully that faucet's being turned up a little bit.
Yeah, I think it's one of those things where when you start a new format, you need devices, you need the ability to actually play content back, and with something like Atmos, you need to be able to hear it. And you need the content itself, and so it takes a little while to get that flywheel going. We did everything we could to drive it forward.
But of course it's up to the studios ultimately, isn't it?
It is, yeah, and when new things come out, it's about figuring out pricing models and packaging as much as it is the technical details. So I think we're through that now, and we're starting to see that steady stream of content.
Well, speaking about sound, you've got a new codec audio codec that's intended for broadcast television. Tell us about that.
That's right. So Dolby AC4 is our brand new audio solution that is designed to be the end-to-end delivery platform for next-generation audio in broadcast standards. It's part of the ATSC 3.0 submission that we have put forward to the standards body, and it's really designed to handle every aspect of next-generation audio in a very, very efficient way.
One of the features of it that I understand is the ability to individually control things like the dialogue level and things like that, which I find great because many people ask me, I can't hear what they're saying. How can I just goose the dialogue? And up till recently, that hasn't been so easy.
Yeah, it's actually one of the key things that people get frustrated by is either the dialogue's too loud or it's too soft, but usually if you gave someone a dial, they would move it. And that's one of the key things that we want to solve. If you think about Atmos to the home and some of the more grand use cases that you can imagine for audio, it's exciting. But at the same time, there's a lot of people that just watch TV with built-in speakers and they want to get a loud and clear experience from the audio. So being able to control the dialogue, simple controls over speech, and the ability to adjust these things is something that we've built into the system.
So aside from dialogue control and so on, what are the other important features of AC4?
Well, we see the future audio experience as something that combines personalized experiences and more immersive experiences. So if you think about Dolby Atmos, bringing that experience to the home with a wider variety of content than just movies is pretty exciting. And some of the experiments we've done around football matches, for example, with the crowd all around you and above you, and the announcements in the stadium really bring it to life. But at the same time, if you think about sport, the real value comes when you get closer to the action and you can understand from your team's perspective exactly what's happening. So experimenting with commentators that reflect your view on the team that should be winning, for example, is a really compelling thing. And we're doing a lot of experiments at the content level to understand how people like to work with that. But we're also building the technical infrastructure to allow the future broadcast to incorporate all of this.
So will AC4 allow for object-oriented bit streams, as in Dolby Atmos?
That's exactly what we're talking about. Yeah, objects allow you to make it more immersive, to personalize it, and any combination of the above.
What kind of bandwidth hit do you take? I mean, does it require more bandwidth than what we're using now?
It's a much more efficient codec, so we can fit the same experience into half the bandwidth, and therefore you have savings, or you've got some bandwidth left to do these enhancements that we're talking about.
Now, getting back to Dolby Vision, one of the displays here in your booth is some production examples, including acquisition, color grading, and so on. Can we go take a look at that?
Yeah, we can. And it's actually a perfect example of, us doing what we were talking about for Atmos in the imaging world. It's important to make sure there's content and the ability to distribute it and also the ability to see it. And that's basically what we're doing with Dolby Vision.
Fantastic. Let's go check it out.
Great.
Here in the Dolby Vision workflow demonstration, we're going to take a look at a couple of the steps that it takes to create Dolby Vision content. What we're looking at now is the capture side of things, and give us an idea of exactly what it is we're looking at.
Yeah, so this is a demonstration of a side-by-side comparison of standard dynamic range content and high dynamic range content that were shot using modified cameras and simultaneously captured in these two formats. The other thing is that we're demonstrating that these HDR signals will work all the way through a broadcast infrastructure without any modification. So we're actually looking at these through a standard broadcast switcher, and you can fade between the two signals and do all of the standard things that you would expect in the standard broadcast production workflow.
What kind of cameras were used?
These were Grass Valley cameras that we worked with Grass Valley to come up with a modified version that would be used for the experimental shoot.
Okay, next up is editing and VFX. We're going to move down the line here.
Yeah, so here we're just showing that we're partnering with a number of different companies in the industry to make sure that Dolby Vision content can be edited very easily and in a streamlined fashion, just using the standard workflow tools that you have. So this demonstration is Adobe Premiere Pro. We're playing the Dolby Vision content natively in the timeline. All of the metadata and the information that we capture in the process of creating that content is retained. And so this gives you a very good and easy way of repurposing and editing content ready for distribution.
All right, and finally we're going to get down to color grading. And this is a really important aspect. All of these are important aspects, don't get me wrong. But with color grading, we actually have to create the content and make the content differently than we did before. So that's a new skill that needs to be learned, right?
That's right. So what we're looking at here is a grading session using some of the custom monitors that we created in order to be able to see what this content could look like. So this is high dynamic range video being graded at its ultimate form in a Dolby Vision mastering workflow. And the great thing about this is that having created at this highest fidelity, we can repurpose this content for distribution in all sorts of formats. And more importantly, when you send that content to those Dolby Vision TVs you saw outside, they know exactly what to do to optimize the picture for the capabilities that they have built in. So it's an end-to-end system. We start at this content creation phase, we distribute the content, and we optimize the experience for consumers in their home.
The two monitors we're looking at here, the one on the left is a standard dynamic range Dolby professional monitor, and the one on the right is the Dolby Vision super duper custom made.
Yeah, only available in small batches.
And what's its peak brightness?
It goes up to 4,000 nits, and it hits more than P3 color.
Now, with Dolby Vision, we have high dynamic range, obviously, but I'm curious to know what happens if that signal then gets sent to a standard dynamic range TV.
Well, there are lots of different ways of distributing content to a television, and to a set-top box, and to a gaming console. So we've thought very carefully about the various ways that you might want to do that. And one of the key ways is using what we call dual-layer encoding. So we take the base layer, which is the standard dynamic range version of the content, and we encode the difference between that and the high dynamic range version, and send those two together. Now, a TV that doesn't know anything about high dynamic range just uses the standard dynamic range version. But a TV that knows how to talk Dolby Vision will use both layers. But that's not the only way of distributing content in high dynamic range. You can use standard codecs and single layer approaches as well. The system's been designed to be really flexible, and we're in an ever-changing and evolving world, and so we're constantly researching new ways to make this work.
Well, thanks so much. It's been great.
My pleasure. Thanks for the time.
Fraunhofer has a number of exhibits here at NAB, and we are thankfully in a very quiet room right now. I'm talking with Merrill Weiss. He's a consultant to Fraunhofer regarding MPEG-H, the audio codec that is being proposed as part of the ATSC 3.0 broadcast standard for Ultra HD. And we're about to see something pretty interesting here. You've got simulated an entire production chain from a remote truck where we're standing now to the New York Network Center to Birmingham, Alabama TV station to a living room in Birmingham, Alabama. Tell us a little bit about MPEG-H and what you're trying to demonstrate here.
So MPEG-H is the latest audio codec from Fraunhofer and a number of other companies that participated in the MPEG standards development process. It is the latest, if you will, in the family that began with AAC, that many people know. It is a codec that's designed to be more efficient, to be more flexible, and we're applying it here in the broadcast and consumer applications of MPEG-H. So it's being used for contribution encoding to go from the remote truck to the network center. It's being used for distribution coding to go from the network center to the affiliate. And it's being used for emission encoding to go from the broadcaster in Birmingham to the viewer's home, as exemplified by the living room that we have here.
Now, does the signal go through various encode decode cycles in that process, or just does it stay encoded throughout the entire chain?
No, it is encoded and decoded. In the broadcast facilities, it's operated in PCM, or those facilities operate in PCM mode, and we're using 16 channels of PCM embedded into SDI. The decoders are professional decoders, so that when the MPEG-H audio compressed stream arrives, what is metadata in the compressed stream is extracted and converted into a control track that travels with the other channels of audio and is treated just like an audio channel and passes through the facilities at the network center and at the local affiliate. That control track carries what becomes metadata when it's in the compressed domain, and it's accessible as a separate channel when it's in the PCM domain.
Now, some of the hallmarks of MPEG-H include object orientation, which allows some measure of individual customization, if you will, in terms of raising the dialogue without doing anything else, choosing one track, vocal track over another, something like that. Tell us a little bit about that.
So what you were just describing is personalization through the use of what are called static objects. Static objects means that the objects are set up for a purpose and they remain available throughout the particular piece of content. So if, for instance, you had multiple languages being carried, you could allow the viewer to choose between those languages by making each language, either dialogue or announce track, a separate object, and then at the receiver the viewer could select among those different language tracks. If you wanted, for instance, to allow the viewer to control the level of the dialogue or of the announce, you can also enable that. The extent to which that's done is under the broadcaster's control. So, for instance, you might allow plus or minus 6 dB variation or plus or minus 15 dB variation, and that's all sent as part of the metadata of the MPEG-H compressed stream. Mm-hmm. So those are static objects. There also are dynamic objects. Dynamic objects are objects that are sent as essentially a mono or multi-channel track or group of tracks. They're sent separately from the main content, and then along with that, metadata is sent that describes to the decoder at the consumer's location where in the sound field those objects are supposed to appear to come from. Mm-hmm. And that metadata then causes a renderer in the decoder to position the sound in such a way to present it on a combination of speakers in such a way that the sound appears to come from the desired location. The thing that's unusual here is that we're actually generating dynamic objects live in real time,
which we're going to see in just a minute. But before we do, I want to mention briefly that this is an immersive sound format. We have not only 5.1, say, or 7.1 in a fairly traditional format, but also height speakers that give that 3D sound effect, which is now so important.
That's correct. The MPEG-H audio system is capable of up to 22.2 channels. It's actually capable of 128 channels and 128 objects. It certainly can handle the 22.2 that is of interest to NHK. It was tested at that level in the MPEG process. We're showing it in 7.1 plus 4 height channels, which is one of the expected sweet spots. The other that probably will be more common is what we're showing here, which is 5.1 plus 4 height channels. Because that can be done with existing audio consoles that are pretty much set up to operate at 5.1. And without any modification to the consoles, without any modification to any of the other equipment that is in use in broadcast facilities. The only change that's required, aside from the actual encoders and decoders, is the addition of a monitoring unit that is specific to the MPEG-H process.
Here in the DTS booth, I'm talking with Geir Skadden, the Senior Vice President at DTS. And last week was a big announcement from DTS. Tell us about it.
Yeah, very excited. We're back in the cinema business with DTS-X and MDA, which is an open platform that allows content owners to use object audio and immersive mixing and distribute in cinema. And here at NAB, we're showcasing how that also translates into home distribution.
Now, MDA, or multi-dimensional audio, is the content creation side of things, which has been around for a while, right? I mean, I've seen demos of that for the last couple of years.
Yeah, that's correct. We acquired MDA when we acquired SRS Labs in 2012, and since then we've been busy together with the original team developing MDA into a broader open format for content creation of object-based audio, yes.
And then DTS-X is the delivery format, if I'm not mistaken.
That is correct. And in the cinema, that constitutes a spec for rendering of immersive audio in cinema. And in the home, it's really compatible on multiple forms of delivery. You can deliver it on a Blu-ray disc that's backward compatible with current players. You can deliver it over the top to home use for DTS-X AVRs, or you can deliver it to phones and tablets where Headphone X is a compatible playback format. Mm-hmm. So we're very excited. We're bringing immersive audio to a broad audience with wide reach.
Now, I noticed that you have a Trinnov Altitude 32 here, which is doing the decoding in this particular demo room, and it was also at the demo at your offices in Calabasas. That's a mighty expensive piece of equipment. I'm sure it's coming out in less expensive AVRs as well.
Yes, we're not able to totally disclose the price point, but I would say mid-range AVRs and up is really what's going to feature DTS-X, which will give end users a broad range of choice, both in terms of manufacturers and price points.
Now, this being an immersive audio format, we're talking about a 5.1 or a 7.1 fairly standard configuration of speakers plus some height speakers. Do you have any guidelines as to where those speakers should be?
Well, the great things about objects is that it actually gives you a lot more flexibility in terms of placement of the speakers. We're not rendering channels. So even in your home, the system will compensate for where you place the speakers. So we're working with the manufacturers to give a lot of flexibility in terms of where you place your height speakers and where you place your sound bed, if you will, whether it's 5.1, 7.1, or even a sound bar. So what you'll find is that each manufacturers will create a user-friendly configuration setup that after you set your speakers and your system up, it will measure where the speakers are, and regardless of your placement, regardless is a big word, but it gives you a lot more flexibility in terms of where the speakers are at, and you will get the correct immersive envelopment from the original cinema mix, which is very, very exciting.
I agree. I mean, I've heard plenty of immersive mixes, and I know plenty of people, and myself included, who prefer to listen even to music even with immersive sound, with 3D sound, which brings up another question, which is, what about legacy content? Because, there's not that much DTS-X content out there yet. So people are going to still listen to CDs, and they're still going to listen to Blu-rays with 5.1 or 7.1 sound. Is there a function in DTS-X that upmixes or expands the sound field into the height channels?
Yes, there is. So if you have the content you already have, if it's 7.1, it will do a upmix to render height out of a 7.1 bed. And so far from the critical listening we've done, we've gotten very good reviews on that feature. At the same time, we're working very closely with content owners and studios who I think are looking at multiple things. One is immersive audio. The other is 4K ultra-high-def video. So what I think you'll find is that catalog is also being re-released with multiple new functions so that you really deliver the next level experience, which is better quality video with UHD, 4K, as well as immersive audio with DTS-X.
Now, are you? I'm sure you're working with the studios. Do we have any? Do we know any titles coming out? Or, I mean, that's up to the studios, not up to you. I know, but are we going to see titles sooner than later that actually have DTSX?
Yes, like you said, we're not in position to announce releases. That's the studios to keep that to themselves. But I would say as the format's coming out in a big way this fall and this year, we're very confident to let people know that this year you definitely will have a compelling DTSX content in your home, no question about it.
Fantastic. Anything else that I've missed that's important to note about DTSX?
I just want to make the point again that I think the flexibility for your setup in the home, as well as having access to immersive content on your phone or your tablet, I think is really what's the most exciting part of this, both for the content owner and the consumer, because it gives you reach to a much broader audience. And I think some of the constraints that surround system had in the past, mainly correct setup of channels or not being able to play it back on anything but surround speakers, has been a big constraint and limited the experience. Now with immersive audio, MDA, and DTSX, this is really an open green field in terms of delivering the next level experience to a broad range of audiences.
One more question I just thought of, and that is there a limit to the number of speakers you can use or the number of objects that DTSX can accommodate in a system?
Well, I think the constraint really becomes amplifiers. So in terms of the technology, the system has a lot more range and flexibility and scalability than what today's home equipment can do, make economically feasible to the end user.
Well, for example, in this room we have self-powered speakers.
Correct.
So as long as you buy self-powered speakers, you could add as many as you want, or is there some upper limit?
I think you could probably compare to a cinema setup. If you think a cinema setup, 48, 60 speakers, I think you can get a lot of speakers for a home. If you went self-powered speakers and had more of a cinema design, if you will. Mm-hmm. But in terms of today, for this release, 11.1 is the kind of the top end of the spec, and that's really working with the manufacturers and what makes sense, both in terms of economic value, amplifier power, and the typical home room setup as well.
Well, and processing power, I would think, as well, and and this 11.1, which is really 7.1 with 4 height channels typically. Yeah. The processing power and the amplifier channels in today's consumer receivers can't really go much beyond that.
That's correct. We have a very close working relationship with all the main parts suppliers, Cirrus Logic, TI, ADI. And I think, working with them, I think there's a continuous source of more power. At the same time, you also want to make sure that you meet higher experience in the economics that makes sense for the manufacturers and the consumer. I think generally the consumer is looking for the experience, but also wants value.
Of course. Well, it's fantastic news, and I thank you very much for joining us.
Scott, great to be here, and have a great show yourself.
Thank you. Well, here we are at the end of a fabulous day at NAB. We've seen a ton of great products, learned a lot of interesting information, and watched some fabulous hula hooping as well. I hope you've enjoyed it as much as I've enjoyed bringing it to you. Until next time, geek out.